class. Welcome back. Today we are going to be learning about our nervous system. This is going to be split into 2 days. So this will be the day 1 section of our nervous system. I'm going to go ahead and present my screen with you. You guys should be on your Google Classroom. This week's slideshow, November 2nd. And then when you're on this week's slideshow, go to Monday's lesson. Same thing like usual. I'll open up the slideshow here in a second. As you see, we're going to do slides 1 through 17 a day. My video will be attached here if you'd rather just listen to me as I'm teaching it to you right now. And when you click here for your assignment, make sure you answer your do now question, take notes within the lesson, and answer any questions I have in the lesson. Some of you guys just do now and one question. I want to see that you guys took notes. And like I said, the more you guys write stuff down, type things up, it processes more in your brain. And that's what we're talking about today is our brain. So when you open up our nervous system, we'll come to our presentation. So to start off in your guys' notes, go ahead and answer your do now. How important is your brain to you? So how important is your brain to you? Okay, I'll give you guys some time. If you need to pause me to answer that. I'm going to go ahead and go on to the next slide. You don't have to answer these questions, but just think about these. How do you remember the way to your friend's house? Like right now, you could just close your eyes or even open your eyes and know exactly which way you go. You might not know the names of all the streets, but you know exactly which way you go. I can still remember the way to my house in California, right? Why do your eyes blink without you ever thinking about it? Now, as we sit here, you might be going blink, blink, blink. We don't do that throughout the day. They just randomly blink. How does that work? And then, of course, where do dreams come from? So this plus like tons of other questions are questions that we probably have in mind and don't really think about. And the answer is because of our brain, our nervous system. So moving on, what does our brain actually do? Well, your brain is literally the boss of your body. Without our brain, we wouldn't be able to do anything that we can do. Unfortunately, if someone goes brain dead, they might be just kept alive based on machines, right? We'll talk about a specific part of your brain that is like a life or death matter for us. So obviously, what does your brain do? It runs the show, controls just about everything that we do, especially when we're asleep, right? Our heart doesn't stop when we're sleeping. Our lungs don't stop breathing. Our body is still working. And if anything, it's working at a fuller potential because your body is able to rest. That's why sleep is so important. All right. So we're going to focus on 5 parts of our brain today. The cerebrum, the cerebellum, the brainstem. This guy, I love saying it. It's the pituitary gland and your hypothalamus. So we're going to focus on those 5 parts in this lesson. So the cerebrum. The cerebrum is the biggest part of your brain. That's this guy right here. I like to call it as the big brain. You'll see why in a second. But it literally is the biggest brain. If you ever hear someone say, put on your thinking caps, that's what they're talking about is your cerebrum. So it's about 85% of your brain's weight. This is like your thinking part of your brain. Like I said, a thinking cap. It controls voluntary muscles. What are voluntary? Those are things like you have to tell yourself what to do. Like right now, I am typing on the computer. You're telling your muscles to type on the computer. When I kick a soccer ball, I'm telling my leg muscles to kick the soccer ball. So those are voluntary. Your brain is telling those muscles what to do. Other examples I put, if you guys need to figure out how to solve a math problem, that's your cerebrum. Figure out a video game, that's your cerebrum. Drawing a picture, cerebrum. What also lives in our cerebrum is something called our hippocampus. Your hippocampus is your memory. That's your short-term memory, your long-term memory. Maybe I could say, hey, what did you eat for dinner last night? Or, hey, remember like years ago we went on that camping trip? What was the name of that hike we went on? And some of you guys, your hippocampus is on fire. We'll talk about tomorrow's session, certain brain disorders and dementia that affects this part of our brain. The cerebrum also helps you reason, like, should I do my homework tonight or should I go hang out with friends? I got a big test coming up. Which one should I do? So it lets you reason a little bit better. All right, moving on. Now your cerebrum comes in 4 lobes, right? As you can see, there's different color of the lobes right here, the red, the blue, the green, and the yellowish orange, right? So these lobes all have a specific name and they have certain functions of what they do. This is why when we talk about brain injuries, it depends on which part of your brain is hit, depends on what type of function or mobility might be lost or damaged. So if you guys are like, well, how do you know which is which part? Well, we'll learn in here in a second. This cerebellum back here, this little guy in the back, we'll learn that's the little brain. Always know that's the back of your head. So if you see a picture of a brain, you already know this is the back of the head. So this red guy must be the front. Since that's the front, that's the frontal lobe. That's like your big forehead, your frontal lobe. What happens there? Your thinking, your memory, your behavior, your movement, all happens in your frontal lobe. Okay. Another easy one to remember is right here on the sides, right? Now it just shows one side. This is it split in half, but you actually have two temporal lobes, right? So your temporal lobes, remember, these are your temples. So it's easy to remember frontal lobe, temporal lobes. What happens here? Well, obviously your hearing, because we talked about how close your auditory nerve is towards the center of your face. You have your feelings. We'll talk about that. I think today or tomorrow, we'll talk about the amygdala, where your feelings come from. The guy on top right here, this like not the frontal, but towards the top of your head, that's your parietal lobe. What happens here is language and touch. So if I get a really bad head injury to the top of my head, my language, my speech development might be damaged or destroyed completely, right? I have to relearn how to talk again if I'm even able to, if those neurons and brain activity wasn't destroyed completely. And the very back of your brain, not the bottom, but the very back of your brain is called your occipital lobe. That pretty much helps your sight. Think, we talked about your eyes, your retinas go all the way back to your optic nerve. It's going all the way back. Well, that part of your brain is where your sight is affected. So if anyone ever like falls really hard and hits the back of their head, their eyes might start going a little like blackish, like I can't really see. And that's why it's really scary with all those specific nerves in our head. Talked about the auditory nerves, talked about the optic nerves. Those nerves, if they get really damaged, that's the quick nerve signals sent to the brain. And that's when we could lose function of those particular organs in our body. All right, we'll talk about the brainstem and cerebellum here in a second. But those are the four lobes. Now, your brain also, if I take my cerebrum, you could cut it in half. Okay, you cut it in half. Have you ever heard someone say, are you a left brain thinker or a right brain? Well, literally it comes in two halves, okay? If you look at your right brain, man, that's all pretty colors. These are the people who are a little bit higher functioning when it comes to music. They might have better talents in music, artistry, shapes, geometric figures, maybe my architects, right? They could see the ways and creativity. My soccer players, my attacking soccer players, they could see how they can get through the field by doing these cool moves, and they could see it, right? Left brain thinkers are more logical, right? These are like your math, there's got to be a solution to that problem. Then there's one solution to it, right? They're more logical, they're more reasoned, they're more analytical, right? Now, I don't want you to think, well, I'm only a right brain thinker. We obviously both have both halves, but some of us might be a little bit more heavier on one side versus the other, okay? Now, the cool thing, what I have here is your right controls your left and your left controls your right. What that means is your right side of your brain controls your left side movement of your body. So if I have a brain injury to my right side of my brain, my left side movement, remember we talked about the frontal brain is your movement, that side could be affected. Same thing if my left frontal brain is damaged, my right movement. Okay, so when we talk about people having strokes, if I have a stroke, a blood clot to the right side of my brain, well, then my left side, my face might start getting droopy, my arm can't move. It controls the opposite movement. All right, moving on. Okay, now we're going to talk about the cerebellum. So that was all the cerebrum. That was the first part I want to talk to you guys about. Now the cerebellum, I call it the little brain. Okay, so if you see in this picture, it's literally the base of your head is your cerebellum. What does your cerebellum do? Yes, it does help with thinking and all the reasoning, everything your cerebrum does. But the main part, it controls your balance, your movement, and your coordination, how well your muscles work together. Obviously, when you guys are first born, our cerebellums are very weak. When we start learning how to walk, we're wobbly, right? We're starting to build and develop our cerebellum. Some of us have better than others. Think of gymnasts. I mean, they could stand on a little 4-inch balance beam and do flips and stuff with not losing their balance. Their cerebellums have been trained to have that precise coordination of movement, right? All right, let's move on. Also, I have a picture here. So if you guys look at this picture, which way is the brain facing? Are they looking to the right or are they looking to the left? And the easy way, like I said, the cerebellum's the back of the head. So if you say, well, back of the head, then this person is facing to my right. Okay, so like I said, some people's cerebellums are just better than others, coordination, but it's also comes with practice. How do you guys get better at math? You practice it. How do you get better on the basketball court? You practice. How do you get better being balanced on a skateboard? You practiced it, right? So you can train your brains just like we train other muscles in our bodies. All right, this is the third part of your brain, the brainstem. I always tell you every lesson we talk about, I'm like, oh, I think this might be the most important. Like the pulp of the tooth, I said was most important. I talked about of your eyeballs, right? We talked about the optic nerve, how important that is, the retina, how it turns it around. So talked about your ear, how I felt like the inner ear, your cochlea, okay, that helps you guys balance, that kind of stuff. Well, same thing with the brain. I feel like the brainstem's the most important because what does the brainstem do? It literally controls our life. So the brainstem is what connects. If you see this little guy right here, it's also, if you've ever heard the word medulla oblongata, that's your brainstem, your medulla, okay? So your medulla is what connects your base of your brain, okay, all the way down to your spinal cord. Your spinal cord goes all the way down to the base of our back, right? Your spinal cord is what houses all those nerves that runs up and down our body, and your brain is the switch that says, hey, I want you to do this. Hey, Coach Goble kicked that ball. Oh, hey, Coach Goble broke her arm. And it sends all those signals to your brain, right? That is the powerhouse of us, right? Now, the scary part is if someone ever has a head, neck, or back injury and that brainstem is damaged, that could be instant death, okay? If someone has a head, neck, or back injury and it might not be fully damaged, the key is do not move someone unless they are in immediate danger. Like if I get in a car accident, you can tell I have a head, neck, or back injury. Don't move me unless you see maybe my car is going to be on fire, my gas tank's going to ignite. Well, then pull me out as safely as possible, right? But if there's nothing, no other dangers, leave me there. Let the paramedics come. They'll brace me up and they'll do a CT scan to make sure everything's intact because one slight movement could snap that brainstem, okay? And it might snap it enough to paralyze me, or unfortunately, it could kill me, right? All right, so this shows you guys another picture of it. So if you guys look here, here's your cerebrum on the top, your cerebellum's a little guy in the back, there's your brainstem. Now, what this brain's not hooked to is not hooked to the spinal cord. So the spinal cord is what would come alongside here, and your spinal cord is what houses all those nerves, right? We'll talk more about that in a second. So your brainstem controls all your involuntary movements, your involuntary muscles. Say, what is that? Your heart, your lungs, your spleen, your liver, your blinking of your eyes, your ciliary muscles, right, of your eyeballs. Everything that we don't have to think about doing is what your brain does for us. Like I said, it does things when we're asleep, we don't realize it. Like right now, we're not saying, hey, heartbeat, oh, my esophagus, squeeze my food down in my stomach, oh, small intestine gets the nutrients out. We don't have to tell our bodies to do that. If we did, gosh, that would be a horrible way to live. That's all we would be doing. Good thing is our brain does it for us, okay? The brain stem necessarily. So if that brain stem is affected, that's when someone might be declared brain dead, and they might need to be hooked up to machines to keep my heart beating, to keep my lungs breathing. Might have to have a feeding tube to keep me eating, that kind of stuff, right? That brainstem also sorts through millions of messages. Like I said, if I break my arm, it's going to send it, hey, that hurt, right? It's going to send all these messages back and forth to the brain, and it's like crazy nanoseconds. Not like it takes a long time. If you put your hand on a hot stove, it doesn't take forever for that message to say, hey, that's hot. You quickly jerk your hand up. That's how quick those messages are sent to your brain. All right, moving on. Okay, the fourth guy we're going to talk about is your pituitary gland. Your pituitary gland is about the size of a pea. It is like the smallest guy in your brain. However, it does one of the biggest jobs, and that means it releases your growth hormone. So when you guys are going through your puberty development years, right, your pituitary gland releases this growth hormone that helps us grow. It also releases growth hormones to make our bones nice and strong. But the crazy part is it is about the size of a pea. Now, like I said, your pituitary gland does a lot of other things, but that's the main thing it does is the growth hormone. And here's a picture of it right here. So here's your brain, right? If you look, this is the frontal, right? Here's your temporal. Here's your parietals, the top, and your occipital lobes in the back. There's your cerebellum, the little brain on the bottom. Here is the medulla oblongata, but it's the brainstem, which is hooked to the spinal cord. If you look right here, this little guy, that is your pituitary gland. Size of a pea, right? It does the biggest job is release your growth hormone. A few other things it does, it helps control our blood sugar level. It also helps our metabolism. All right, fifth guy in our brain that we're going to talk about today is called your hypothalamus. Now, if you look right here, your hypothalamus is like right on top of your pituitary gland, right? This little center area. This brain's obviously cut in half so we can see the hypothalamus. What does your hypothalamus do? It's like your body's inner thermostat. So when your body gets too hot, right? If you guys know what is our normal temperature should be, 98.7 degrees, right? So if you guys get too hot, like if you start having a fever, or it's summertime and I have my soccer kids out there working out, it's like 110 degrees outside, their body gets way too hot. What do we end up doing? First thing we do, we sweat. When you sweat, that's your hypothalamus saying, whoa, you're way too hot. We need to start lowering this temperature down, so you start to sweat. If you're running a fever, you get those cold chills because it's your body trying to say, whoa, this is way too hot. Unfortunately, if people don't listen to their bodies, right, their hypothalamus might not be telling them or helping them out as much because it could only do so much, right? Say I'm not listening to my body, I'm just working out harder, or that fever just spikes and it goes higher than normal. Okay, this is when we could be in heat exhaustion, heat stroke, which can lead to death. That's scary. Our bodies, as we get into this like prime age, we have a fever, 101, 102, keep an eye on it. Babies and elderly adults, that could be crucial for them. So 1 or 2 degree spike can be scary, right? Now it's the same thing, the opposite. We just had this huge ice storm. So our body should be 98.6, 98.7, right? So if it goes lower than that, okay, when you get cold, what do? We have those chills, right? We get those goosebumps. You start to chatter because that's your body's way of trying to give you some movement to warm up. Now, like I said, your body can only do so much. If I'm stuck in those elements for a long time, I could go into hypothermia. Hypothermia is when my body gets so cold and it starts to slow down my functions, right? So same thing, if it gets way too low, your body will try to do what it can to get back up to the degrees it needs to be. So your hypothalamus is your brain's inner thermostat. All right. When we talk about our drug unit, one thing with the hypothalamus, we'll talk about our drug unit. There's one drug, you guys heard of Molly, Ecstasy X. We'll talk about that. It's known as like a rave club type of drug. The scary thing with X is Molly's is it blocks out your hypothalamus. So as I'm saying, yeah, it controls you high, it controls you low. What happens is people start getting like dancing, they're getting way too hot, but the ecstasy literally wipes out the hypothalamus, so they don't realize how hot they're getting until they're on the ground having a heat stroke and possibly death. Okay, so that's just a little tidbit what Molly's do to your hypothalamus. All right, moving on. Okay, now we're going to talk about your spinal cord nerves. We just talked about the 5 components of your brain, right? We talked about the different lobes, what they do. Now we're going to talk about this brain that hooks to this long spinal cord. What is your spinal cord? It hooks to the base of your brainstem all the way down to the base of your back, right? It is literally a long bundle of nerves. Think of it like if you know a big extension cord, one of those big orange extension cords. If you peel off the orange outer layering of it, you're going to have all these exposed wires, right? And if I have it plugged in somewhere and you touch it, right? That's scary. You don't want to do that. So think about like your spinal cord is like a big extension cord plugged into the base of your brain. Okay, and if I undid all that like orange protective covering, I'm going to see all the exposed wires, which would be the nerves, right? So this is what let messages flow up and down that spinal cord to your brain. The scary thing with it is, I told you, if I have an injury to the base of my head, my brainstem, that could be imminent death, or it could be a really close chance of being paralyzed quadriplegic. So say I have an injury on the upper part of my spinal cord, right? I fall off a horse, I fall off an ATV, I wasn't wearing a helmet, I mean, anything, I have an injury, and I have an injury to the upper spinal cord. Well, my brain's functioning perfectly, right? Hopefully the doctor is able to take care of me. My brain's functioning perfectly. Well, that message is just trying to say, hey, go down and move your arms. When that message goes down here, it's literally broke, right, so to speak. So it's not going to get the message down. So I literally can't move anything below wherever that injury was. So if it was up here towards my neck area, I cannot move anything below it. Okay, now everything on the inside of my body is functioning because my brain has those involuntary muscles. But my voluntary movements, I cannot do because my brain's saying, hey, go move your legs. And it's saying I can't. That part of your extension cord broke off. Same thing if I have an injury lower down to the base of my back, right? My lower back, my lumbar unit. Same thing. I could tell my brain, hey, go move your arms. Cool, I'm moving my arms. Okay, move your abs. Okay, move your legs. You can't, right, if that part is broken. So that's why it's really scary to have a neck, back, or head injury. All right. What are neurons? So neurons, are like our brain cells. They're very microscopic. We have about 100 billion neurons. The cool thing is, guys, we have so many neurons in our brain that we could do anything we want. Like, seriously, if you want to learn how to speak French, connect those neurons. You want to learn how to throw a football, connect those neurons. You want to learn how to do calculus statistics work those neurons. Same thing, is just you got to practice it. As much as we train our outside muscles, you got to train that brain. So you got to think every time you guys learn something new, it's like these neurons synapse and they connect. Okay. To go a little bit more into what a neuron is, you guys will learn this more in biology, or if you guys go to human anatomy. But your neuron is made of this big axon, right? And that has these little dendrites, like little branches that come off of it. Okay, they want to synapse with other neurons. So say I learned 1 + 1 = 2, it synapse, create like a brain cell, right? That little brain wrinkle, think of it like that. When I learned how to kick a soccer ball, synapse. When I learned how to do, like I said, my calculus homework, synapse. When you're learning about your nervous system, synapse, right? So they start synapsing. Every time you learn new things, they connect, right? When we talk about alcoholism and drug abuse, unfortunately, a lot of these drugs and alcohol, they make these neurons disconnect, okay? If someone has a brain injury, these neurons could disconnect. So you say, why does this person not know how to hold a fork? Because that neuron, when I learned how to hold a fork, when I was like 1 or 2, connect. Well, if I had a head injury in that area, it could have disconnected these neurons, which makes me have to relearn how to use them again. All right, moving on. I want to show you guys some interesting brain facts. Go ahead and write a few of these down. So crazy thing is, your brain generates nearly 25 watts of power while you're awake. So it's like enough to light up a light bulb. That's how much activity. When they say it's an electrical system, we pretty much do have an electrical system in our body. We talked about how alcohol interferes. We'll talk more about that in a second. Anytime you have a new thought, that's the connections, right? This is interesting. A living brain is so soft, you could actually cut it with a table knife, right? You could just cut it with the table knife. And with that being said, look at this one down here. There's no sense of pain within the brain. So if someone's having like brain surgery, usually if you have surgery, they numb that area up. They put you under anesthesia. Well, if your brain, I could be alert. If they're cutting into my brain, now if they're cutting into my skull, obviously they're going to want to numb that area, right? Not my skull, but my scalp, they'll have to numb that area. But when they get to my brain, I don't feel it. Your brain doesn't feel the pain. It's the neurons that let you feel the pain, right? But your brain doesn't feel it. So they could be cutting into you and you don't feel pain itself, right? Look at this one. So when it comes to brain damage, loss of oxygen, we're going to learn in our respiratory system is we need oxygen to survive, right? If someone goes unconscious and they're not breathing, loss of oxygen for just 5 to 10 minutes can cause serious brain damage. Your brain can stay alive for about 4 to 6 minutes without oxygen. After that, the brain cells start to die off. That's why it's so important. If anyone stops breathing, we got to call 911 immediately. If you know how to do CPR, we got to start getting oxygen in their body, because after about 5 to 10 minutes, their cells start dying off and they could be declared brain dead. You will lose consciousness 10 seconds after the loss of blood supply to the brain. So if I get in an accident and if all of a sudden I don't have blood supply going to my brain within 10 seconds, I'll lose consciousness, right? And then, like I said, within 4 to 6 minutes, I'm starting to lose brain cells if I'm not getting oxygen to that brain. All right, so that is our lesson for today. Let me get you guys out of here. So today we, like I said, talked about the 5 main components: your cerebrum, which is like your thinking cap; your cerebellum, the base of your brain, which is like your balance movement more so; your pituitary, small little guy, but he does like your growth hormone; your hypothalamus, which evens out your body's temperature; and then the most important, in my opinion, is your brainstem, because without it, your heart wouldn't be beating, your lungs wouldn't be breathing, your esophagus wouldn't be squeezing your food. We wouldn't be able to function, right? Then we talk about the different lobes of your brain. That's why if you have a different brain injury, depends on what part of your head you hit, depends on what function or learning capacity might be affected, right? Tomorrow we'll talk about brain issues, brain disorders, and how to take care of your brains. But I'm going to tell you right now, protect yourselves. You got to wear a helmet. Wear a helmet if you're riding your bike, you're riding a motorcycle, an ATV. Challenge your brain. Just like if you want to get strong muscles on the outside of your body, well, you want a strong muscle in here. We have the ability to learn. It's just up to us. Are we putting in the work to do it? All right. So I hope you guys learned. Tomorrow, like I said, we'll finish this unit. And don't forget, subscribe down below. See y'all.